So before we begin our lab today, there are a few topics that we didn't quite get to yesterday, but that will be important for us to understand before we begin the lab today. So this is a continuation of our note 11.3, the ray model of light. Now we're entering into the section of the chapter where we start to get into the technical details of light rays and geometric optics. So we're going to start with the simplest situation, which are our flat mirrors. So I think most of us are aware that the reason we are able to see images in mirrors, specifically flat mirrors, is because light rays, either from a luminous source or that bounce off a luminous source, are hitting that reflective surface and moving towards our eyes. And that's what allows us to, our nervous system, to process those light rays into an image. So a couple of definitions before we begin, some special terms. Now I think all of us know what a mirror is when we see it, but things that are considered to be mirrors may not be sort of your typical what you'd see in your bathroom or in your hallway to let you see what you're looking like. A mirror technically is any polished surface that is going to cause light to reflect off of it. So there are many surfaces that aren't true technical mirrors, but they can act as mirrors. So really, when we're looking at a mirror, we're looking at just there being a really smooth reflective surface. Even our windows can act as mirrors. So some terminology specific to this unit, though. When we say a plane mirror, not P-L-A-I-N, but P-L-A-N-E mirror, we really just mean a flat mirror. So when we talk about there being a flat plane, we really just mean a flat surface that is two-dimensional. So just to give you some insight as to where this term plane comes from, when we talk about a plane in geometry or in math or whatever, physics, we're talking about sort of a flat two-dimensional surface. So once you get to grade 12, you'll realize that in order for things to be drawn three-dimensionally or represented three-dimensionally, you need to have not just your x and y axis, but your z axis, almost sort of like it's coming out of the board. So I can talk about maybe, say for instance, the y plane, and that's the blue plane right here. And notice that it's flat and two-dimensional. I can talk about the xz plane, and that's the pink one here. And I can talk about the yz plane, and that's the green one. So notice that they're all sort of a flat surface, similar to the way that a mirror would be reflecting light. That is, if it's a plane mirror. So in science, we have some special symbols that represent a mirror if we're drawing it. So if we're looking at an actual mirror, we know that we have the typical mirror that's meant to be a mirror will have this reflective thin film on the back, and usually it's some sort of reflective metal, like some sort of silver colored metal, and it's really, really thin. In fact, some mirrors you can actually peel off that thin sort of foil on the back. But it's covered by this protective glass that it has a certain thickness. So how we represent this, if we're looking at it in the same orientation, is we have the reflective surface at the front, and that's represented by a solid line. And then so that is your reflective surface. It's analogous to this reflective thin film here. And then you can see these hash marks here. Okay, it's a hatched border, and that is represents the behind the mirror stuff. So this would be the front of the mirror, and where the solid line is, and where the hatch marks are sort of behind the mirror. So for example, if I were to draw, a diagram of that, just imagine, let's pretend that's a straight line, and then I showed some hash marks here, boom, 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 and so on, then, really my incident light would be, oopsies, I don't know what happened there. Let me do that again. If this is my hatched edge right here, then where would my incident light be coming from and moving towards? Well, let's see if you got this right. My incident light would be coming this way and hitting, because this would be the front surface of the mirror, and right back here is the opaque side or the behind the mirror part. So hopefully now when you look at this mirror here, you can see that this is a plane mirror, it's flat, and that those hatch marks there tell you it's a mirror. So some other terminology you're going to need to know today. We talked about incident ray and we talked about reflected ray yesterday. So I think those are okay. The incident, remember, is the ingoing light. And the only way that I know that is by the direction of the arrows. The arrows are, need to be there. That's critical. Now another line is called the normal. And the normal line is a line that you draw perpendicular to the surface of that mirror. Okay, so if this is where the incident ray is hitting the surface of the mirror, then the normal is drawn perpendicular to that plane. So you can see that there's a right angle symbol here indicating that this is perpendicular or at a 90-degree angle. So the normal is basically, if we had to define it, would be a line drawn perpendicular to the surface of a material. Okay, so it's important for you to understand also that when we measure what's called the angle of incidence, we're not measuring it relative to the surface of the mirror right here. We're measuring it relative to the normal line. Okay, so say for instance, I know that this whole angle is 90 degrees. And so let's say I knew that the angle to the reflective surface was, let's say, 50 degrees. Then I would know that my angle of incidence were 40, right? So we're always measuring relative to the normal. The angle of reflection is similar. It's analogous to the angle of incidence. We're just measuring relative to the normal. So that's really important for you to understand. So while we're waiting for our class members to finish their quiz, what I want you to do is just take a quick minute to read through the details of the lab and to get started. So the first thing I want you to do is to read through the first few sections, including the procedure. And based on what information we're collecting and based on what is described in this first paragraph here, I want you to come up with basically what the essential question of the lab is.